Hello class, and welcome to today's algebra lesson, which is about slope-intercept form. By the end of today's lesson, you will be able to write and graph equations in slope-intercept form. First, we're going to talk about what slope-intercept form actually is. This is a specific way that we can put linear functions onto a graph. It is one of the forms that we're going to have for our linear function. It is the most common one that you'll see used during algebra and beyond. So what does slope-intercept form mean? First, the M stands for your slope. That's what we talked about in our last lesson. We can find slope by doing y2 minus y1 over x2 minus x1, or they may just give you the value. So we have slope as part of our equation. The other part then is our intercept. That is this plus b part. The intercept that we are talking about is the y-intercept, so where the graph hits the y-axis. So we've got our slope-intercept form because our slope is being multiplied with the x, and then our intercept is being added, or it could be subtracted at the end of the problem. So we're going to start by just writing equations in slope-intercept form. And in this one, it asks to write the equation in slope-intercept form for a line with a slope of 4/7 and a y-intercept of 5. So your m value is going to be 4/7 and your b value is going to be positive 5. So that means your final equation is going to be y equals 4/7 x plus 5. And that is our equation in slope-intercept form with our given information. Go ahead and try this one on your own. So we've got y equals negative 2x minus 14, because our slope is negative 2, and our y-intercept is a negative 14 instead of positive 14. Sometimes it's going to be a more complex scenario. So in this case, the number of job openings in the United States during a recent year increased by an average of 0.06 million jobs per month since May. In May, there were about 4.6 million job openings. Write an equation in slope-intercept form to represent the number of job openings. So the first thing we want to try to identify is our slope. When we are doing a longer word problem, you're going to look for some key words. In this case, it is per. You might also see each. You might also see changing. So that is what is happening continually over and over, what is allowing us to get from one month to the next month. So the 0.06 is going to be our slope value. The other piece then of our equation is our y-intercept, or our b value. That is the starting point. So in this case, we're talking about since May. So the value in May, the 4.6 million, is going to be our starting point. Then all we have to do is plug our values into our equation. So I get y is equal to 0.06x plus 4.61 as my equation in slope-intercept form for this scenario. Go ahead and try this one on your own. In this case, your b value is 183 million. That's where it starts. And then this one says it is decreasing by 9 million per year. So we are going to subtract or have a negative 9x. Some other times they give us an equation and we need to rearrange into slope-intercept form. So our goal here is to be able to solve and isolate so that y is by itself. The first thing you're always going to want to do is move the x, or the number, away from the y. So in this case, I've got a negative 22x, so I'm going to get rid of negative 22x's by adding 22x's to both sides. That eliminates the piece that is over on the side with the y. So now I still have 8y, and then I have 22x and 4. Those can't be combined because the 22 has an x and the 4 does not. In order to keep it in slope-intercept form, I'm going to write my 22x's first and then I'm going to add 4 to that. The reason I added the 4 is because the 4 was positive. The next piece I'm going to do is then divide by 8. Because there are 2 pieces on the other side of the equation, both values need to get divided by 8. So we can't just divide the x's or just divide the 4. Because there are 2 pieces on the other side, we have to divide both of them. So I end up with y is equal to, 22 can't actually be divided by 8, but I can reduce that to 11/4. We always keep our slope value in a fraction. We are never going to convert that to a decimal. And then we have plus 4/8, which once again cannot actually be divided, so I'm going to reduce that to 1/2. If you wanted to change your y-intercept, so that b value, to a decimal, that is acceptable. So if you would prefer to have 11/4 x plus 0.5, that is okay. But your slope, the m value, should always either be a whole number or a fraction. It should never be written as a decimal. Go ahead and try this one on your own. So we just subtract the 16x to isolate the 4y, and then we're going to divide by 4 on all values, giving us y is equal to negative 4x minus 14. Now we're going to get into graphing in slope-intercept form. This is a 4-step process where really the first 2 are the actual steps. The first thing you are always going to graph is your y-intercept. Once again, I said on that first definition slide, the y-intercept is the starting point or the original place of the graph. So you're going to graph the coordinates 0, b. Then the second step is, if necessary, you're going to make the slope a fraction. If it's already a fraction, great. If it's not, you're going to turn it into a fraction. Then you're going to use the slope to graph a second point. You could repeat that and graph a third or a fourth or a fifth point if you wanted to, but you technically only need 2. And then you're going to connect your points with a straight edge. The line should be all the way through the whole graph, and it should have arrows on the end. So we're going to start by writing and graphing an equation in slope-intercept form for a line with a slope of 4/5 and a y-intercept of -2. So my first step here is going to be to actually write the equation. So I have y equals 4/5 x minus 2. So that's the equation that I am writing. Now I need to go ahead and graph it. So the first thing I am going to do is I'm going to pull out my y-intercept, which is going to be 0, the b value, which is -2. That is the first coordinate that I am going to put on my graph. Then I need to use my slope, which in this case is already a fraction, to get to my second coordinate. When you are looking at your slope, the numerator always tells you whether you are going up or down, and the denominator tells you whether you are going right or left. The up and down depends on if it is positive or negative. The right and left depends on if it is positive or negative. So in this case, my slope of 4/5 would mean 4 up because it is a +4 and 5 right because it is a +5. That starts from your y-intercept. So we graphed 0, -2. Now my slope tells me to go up 1, 2, 3, 4, and then to the right 1, 2, 3, 4, 5 spaces. Those are the only 2 points you need on the graph. If you wanted to put another point on the graph, you could use your slope again and go up 1, 2, 3, 4, and to the right 1, 2, 3, 4, 5. So you can put on a third point if you would like. You also could move the opposite direction. So instead of going up and right, We can do the opposite and go 1, 2, 3, 4 down, and 1, 2, 3, 4, 5 to the left. Again, you don't have to do that. The only points that you needed were these first 2 points. The last step then of our graph is going to be connecting with a straight edge. So when I do that, I'm going to draw through both of my dots and all the way through my graph. And then I'm going to go ahead and again add those arrows onto the end to say that my line does not stop just within this particular picture that we have, but that it keeps going on forever and ever. Go ahead and try this one on your own. So you've got your y-intercept of 0, 4. Then your slope of -3 means down 3 and right 1. So we go down 1, 2, 3 spaces and to the right 1. Connect with a straight line going through both of our points and adding arrows onto the end. Next, we're going to go through and we're going to rewrite the equation in order to be able to graph it. So I have to start my 3x minus 4y is equal to 12. First thing we need to do to get y by itself is to get rid of those 3 x's. So I'm going to subtract 3x on both sides of my equation. So I end up with -4y is equal to -3x plus 12. Again, remembering we want our x's in front of our intercept. Then I'm going to go ahead and divide each piece by -4 because I want it to be a positive y when I finish. So I have y is equal to negative and a negative make a positive. 3 cannot be divided by 4, so I have 3/4 x. And then I have 12 divided by -4, which is going to give me a -3. So now when I do my graph, my y-intercept is going to be at 0, b, or in this case, 0, -3. So I go down 1, 2, 3 for that initial point. And then I have a slope of 3/4, which is telling me to go up 3 and to the right 4. So I go up 1, 2, 3 spaces and to the right 1, 2, 3, 4 spaces. Again, you could repeat that and go up 1, 2, 3 again, and to the right 1, 2, 3, 4 spaces again. And our final step is going to be to connect through those points with our straight edge all the way through the graph, and then add those arrows onto the end to say that it continues going forever and ever. Go ahead and try this one on your own. So we start by adding 2x to both sides, then dividing by 5, which is going to give me 2/5 x plus 2. So my y-intercept is at 0, 2, and my slope tells me to go up 2 and to the right 5. The last piece we have is if it is just a single variable. So if it is just a single variable like this one is, we do have to do a step to solve for this problem because the y is not isolated yet. So I'm going to go ahead and solve the problem by dividing by 2 on both sides, which is going to give me y is equal to -2. When you end up in a scenario where you only have one variable, you do need to go back to using that table method to graph. So in this case, your y value for all 3 points is going to be -2. And then your x values is going, not -0. Your x values are going to be -1, 0, and 1. So as I do my graph, -1, down 2, 0, down 2, and 1, down 2. And then we're going to connect with our straight edge all the way across the graph, which is going to give me that horizontal line, and adding my arrows on to the end. Go ahead and try this one on your own. So in this case, nothing to solve to isolate. I just have x is equal to 6, which means I plug in -1, 0, and 1 for my y values, giving me the vertical line. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.